rational exponents. What you need to know is the following. If you have the 8th root of x to the b, x, the upper fraction is the power. This goes up as, that's the numerator, and this goes in the exponent as the denominator. Now, if there is no number equivalent to the b, that is, there is no number right there, what you need to do is be mathematically mature enough to realize it's 1. So then it's x to the 1 over a. If there's no number out there, it's understood by definition to be a 2. It's always understood. That's why we call this the square root of x. It's understood to be the second root. It's understood to be a 2. So it's x to the b over 2. Now, if you just have this, the square root of x, well, you need to understand that there's a 1 here and there's a 2 there. It's understood to be there. So you get 1 over 2 as the exponent. The square root of x is the same as x to the 1 over 2. Okay. Just as simple as this. B over a, just have to know where to look. That's the numerator, that's the denominator. So, if you're, first let's assume all variables are positive. And we want to write it in exponential form. So if you have x to the 5th, whether you write this next step or not, whether you write it or not, that's up to you. But you have to understand that there's a 2 there. So then you say 5 over 2 for the exponent. 5 over that understood 2. So the instructions were to write this here in exponential form. Well, there's the answer. If you were asked to write this in exponential form, you would write 8 raised to 5 over 3. You had the 7th root of 11. You need to be mathematically mature enough to know that there's a 1 for the power of 11. 1 over 7. I don't care how complicated what's inside the brackets are. 3a cubed b to the 7th to the 3rd 11th root. This will equal 3a cubed b to the 7th raised to the 3 over 11. Okay, this is very similar to this problem. This would be x to the 3 over 11. What if you come to learn that x was 3a cubed b to the 7th? So instead of x, you put 3a cubed b to the 7th. Exactly like we did up here. The whole thing gets raised to the 3 over 11. Even if it were a sum, plus 2, plus 2. The 3a cubed b squared b to the 7th plus 2, all in brackets, to the 3 over 11 power. possibly I did that one a bit quick. The point I'm trying to make is, doesn't matter what's in the bracket. It's going to be what's in the bracket to the 4 over 7. 4 over 7. I don't care what's in the bracket. If it's 3a plus b, fine, it's 3a plus b to the 4 over 7. Now, let's reverse the game. What if I give you x to the 3 over 7, and I ask you to write it in radical form? This is in radical form because it has a radical. This is in exponential form because it has an exponent. Well, just remember, the numerator goes here, and the denominator goes here. 1, 2, 3. 24x to the 71st to the 11 third power. Well, 2y x to the 71. The numerator goes here. The denominator goes right here. You had 3a plus 4b squared to the 1/2 power. 3a plus 4b squared. There's really no point in putting the 1 up here, because that's the numerator, 1. And the 2, there's no need to put the 2 there. If you did, it wouldn't be marked wrong. Possibly, your teacher really wouldn't want you to write that 1. But you can definitely write the 2. But the 2 is understood to be there if you don't write it. There's a nice answer. Okay. Now, let's talk about how we simplify these things. Again, we're assuming all variables are positive. We're assuming that all the variables are positive. You have y to the 12th with a 2 out here. You do 12 divided by 2. And you get 6 with no remainder. Remainder 0. Okay? So you have a y in front and a y under the radical. This 6 goes here, and this 0 goes here. Now y to the 0 is 1. Y to the 0 is 1. So the square root of y to the 0 will be the square root of 1, which is 1. And this times 1 is just y to the 6. The remainder is 0. Don't even bother keeping it. It's just y to the 6. If you were asked to do or to compute the cube root of x to the 17, well, you're going to have an x in front, and you're going to have a cube root of x to some power. Possibly. Maybe it will be 1 again. But what you do is 3 into 17. 3 into 17, it goes 5 times, remainder 2. There's the 5 times, there's the remainder 2. It's x to the 5th times the cube root of x squared. It's just long division. It's just long division. If you had the 4th root of 5 to the 6th, a to the 7, b to the 8, c to the 13, well, Part of the answers might have 5, A, B, C in front with various powers, fourth root, and the same things underneath the radical sign. Now you just do long division. 4 into 6. 4 into 6, it goes 1 times, remainder 2. So 1 and 2. That's for the 5. Now for the A, you do 4 into 7. Goes 1 time, remainder 3. 1 time, remainder 3. B, you do 4 into 8. It goes 2 times, remainder 0. 2 to 0. 4 into 13. Goes 3 times, remainder 1. 3, remainder 1. And now we just clean it up. 5 to the 1 is 5. A to the 1 is just A. B cubed, B squared, C to the third. Times the fourth root of 5 squared is 25. Times A cubed. B to the 0 is 1. I won't bother writing that, because multiplying by 1 doesn't do anything. 25 times A cubed times 1 is 25A cubed. Times C to the 1, which is C. And there's the answer. It's just long division. It's just long division. Numbers or a head. You had to know what 5 to the second was. When it was 8 to the second, you just left it as 8 to the second. When it's 5 to the second, you have to know what that is. It's just long division. Suppose you have this problem. The square root of x squared y, the square root of that. Well, let's figure out what this is first. And then we'll take the square root of it. Well, that's x squared y to the, let me write it down here, square root of x squared y. This power not being here is 1, and this number not being here is 2, so it's to the 1/2. So you have x squared y to the 1/2. Now, what does this do? Well, this is, alright, so, okay, here. Let me not do it differently now. It's x squared y. It's this number divided by that. 1/2 divided by 2 is a quarter. You have $half, divide it between two people, they each have a quarter. And after all, multiply top and bottom by 2. The top is 1. 1/2 times 2 is 1. 2 times 2 is 4. So it's 1/4. X squared y all to the 1/4 power. Now, let's talk about how to evaluate these type of expressions, these rational expressions. Suppose I give you 8 to the 2/3 and say, how much is that? First thing you ask yourself, you deal with the denominator. What do I multiply by itself 3 times to give me that number? A lot of students say, I don't know. Fine, don't know, but try. Multiply 1 by itself 3 times. Get too little. Multiply 2 by itself 3 times. 2 times 2 is 4, times 2 is 8. 2. To the second power. Multiply that answer 2 by itself 2 times, get 4. Somebody asked you what 32 to the 3/5 power is. Okay, the answer turns out it's going to be 8. But how do we get 8? This is asking a couple of questions. What times itself that number of times gives you that number? Well, it's not 1. 1 times itself 5 times is 5. Try 2. What's 2 times itself? 5 times. Well, this is 4 times another 4 is 16 times 2. Oh, it's 32. It is that number. So it's that answer. What times itself? 5 times gives you 32. 2. Raise that to the 3rd power. That is, multiply that answer by itself 3 times. 4 times 2, get 8. Suppose you had 64 to the 3/2 power. What times itself 2 times gives you 64? You should just know that. It's 8. Well, let's make it 4. Okay, so it's 8. And then you cube 8. 8 times 8 is 64 times 8. I think that's 512. Wanted to stay away from this problem because I didn't know what 64 times 8 was. Okay, so it is 512. So what if I have 64 to the 5/3 power? I think that answer is 1024, but I could be wrong. What times itself 3 times gives you 64? Well, 3 times 3 is 9, times 3 is only 27. It's not 3. What times itself 3 times gives you 64? Well, 16 times 4. Oh, that's 64. So I want 4. What times itself 3 times gives you 64? 4 to the 5th power. 4, 4, 4, 4, 4. 4 times 4 is 16, times another 16. I think that's 256. Times another 4 is 1024. So 4 to the 5th is 1024. Know the rules. Know the rules. Now, sometimes you just can't figure out the answer to the first question. Like if I gave you 3 to the 2/5 power. What times itself 5 times gives you 3? Well, it isn't 1. That's too little. But it isn't 2 either. That's too big. 4, 8, 16, 32. Notice I'm multiplying 5 times. So then you can't do that. So you square, so keep in mind that this is really 3 squared to the 5th root. 3 squared is 9. So the best you can say is it's the 5th root of 9. Now you could have done this with your earlier ones, but you don't want to raise the powers first. See if I have any of them. 8 to the 2/3. 8 to the 2/3 we realized was 4. Remember, we asked ourselves what times itself 3 times gives you 8, and it was 2. 2 times 2 times 2 is 8. And then I squared the 8 and I got 4. So in all my work, I never went past 4. Never did anything other than 2 times 2. Now, if you say 8 to the 2/3 is 8 squared the cube root. This also works. However, look at the price we paid. We now have a big number. What times itself 3 times gives us 64? My question was, over here on the left, what times itself 3 times gives me 8? Now we're asking, what times itself 3 times gives me 64? That's a much harder problem. If you don't think that's what it's asking, remember it's 64 to the 1. So it's 1 divided by 3. It's asking, what times itself 3 times gives me 64? The answer is 4, but the numbers are bigger. We have 16s now. You know what 16 times 4 is? Okay, I definitely wouldn't do it that way. The only time I would use a radical form is if I don't know what times itself this number of times gives me that number. If I don't know that, then I would do the power first. The only time I would do the power first. The numbers get pretty big. Okay, so if somebody asks you what 11 to the 2/3 is, you don't know what to multiply by itself 3 times to get 11. I mean, 1 times itself 3 times is 1, 2 times itself 3 times is 8, and 3 times itself 3 times is already bigger than 11. So we can't do that. So I know that that cube root's going to remain. Do 11 squared, 121. Cube root of 121. That's what you should get when you simplify this. You get the cube root of 121. Now, if somebody asks you what 4 to the 1/2 is, what times itself 2 times gives you 4? 2. So the first power is still 2. In alternate ways, you can say, oh, 1/2, I know that, like I know my name. It means square root. Square root of 4, it isn't a hard problem. It's 2. Now, what if they ask you what negative 4 to the 1/2 is? What times itself 2 times will give you negative 4? I like to think there's 3 types of numbers. Negative numbers, the number 0, and positive numbers. One number times itself 2 times gives you negative 4. Well, if you multiply 2 negative numbers, if you multiply a negative number, by itself 2 times, you'll get a positive. If you multiply 0 by itself 2 times, you'll get 0. If you multiply any positive number by itself 2 times, you will get back a positive number. You never get back a negative number. There's no solution. You cannot take the square root of negative 4. There is no solution. You cannot take the square root of a negative number. You cannot take any even root of a negative number. What would be the 4th root of negative 16? Whether it's written that way or it's written this way. What times itself 4 times will give you negative 16? Well, again, 3 types of numbers. You multiply a positive by itself 4 times, you get a positive. Multiply a negative number by itself 4 times. Positive times positive will be positive. 0 will be 0. You'll never get a negative. So this here has no solution. Now, I was always told by my teachers, you can always replace equals with equals. And then one day, I found out that's not always true. That's not true with exponents. If somebody asks you, what is negative 2 to the 4/2 power? What is negative 2 to the 4/2 power? Well, you may want to say, well, 4 over 2 is 2. Oh. All right. Well, that won't work either. Maybe this is a problem. Let's see. This becomes 4. That we know. Now, negative 2 to the 4th power square root. 2 to the negative 2 times itself 4 times is 16, which is 4. So what's bothering me? Suppose you have negative 2 to the negative 3 over 6. To the 3 over 6. To the 3 over 6. 2 over 6. 2 over 6. Now, what you can do is, you can square first, and then take the 6th root. So you're taking the 6th root of 4, which can be done. The 6th root of 4. Take the calculator, it'll give you a good approximation. But here's where we have trouble. We'll do it. 2 over 6 is 1/3. But you can take 10. I don't know. I'm not seeing it right now, but when you play games with exponents, you can get burnt. I know that for sure. Let's see if we can work backwards. And let's see if we can work backwards. Negative 2 to the 1/2. That is the square root of negative 2. This has no solution. Can't take the square root of a negative number. However, 1/2 is the same as 2 over 4. So now you do negative 2 squared, and you take the 4th root of that. Negative 2 squared is 4. So now I get the 4th root of 4, which is a real number. Okay, so here's a case where it worked out nicely. Let me do 16. 16 to the 1/2. That's the square root of negative 16, which is no solution. So now, if I do negative 16 to the 2/4, which equals 1/2, this is negative 16 squared, the 4th root. Negative 16 squared is 256, which is 4. Okay? It's a coincidence that those numbers are the same. For what times itself 4 times gives me 256? 4. 16 times 16 is 256. So these are not equal. These are not equal. Because the top one gave me no solution, the bottom one gives me 4. You cannot play games with the exponents. Whatever exponent you're given, don't change it. Don't change 1/2 to 2/4. Do not change 2/4 to 1/2. It cannot be done. And not that I'm any better than the people I'm going to comment on. I showed this to some pretty good mathematicians, and they're like, oh, I never noticed that. They just never looked at it. This is too low level for them. This is arithmetic. They do much higher math. They were shocked. They were shocked. So, if your teacher makes this sloppy mistake, just point it out. You cannot always replace equals with equals in exponents. If you know any other places where you can't do that, let me know. I guess I know of one other place. You have the log of, you can't take the log of negative numbers. So, if you have negative 2 squared, you cannot bring the power down. So I guess what I'm saying is you need to be very, very careful if you want to say these are equal, 2 squared. If you want to say they're equal, you have to be a little bit careful. You have to be a little bit careful. Those are equal, because I am taking log of 4, but you can't bring down the power. Okay, that's just an exception to the rule that says you can bring the power down. The rule should state, and I don't think I've ever seen it this way. It should say you can bring down the power, provided that A is positive. Okay, so be careful with exponents. It can really get you into trouble. Now, if you have something like 4 to the negative a half, something is being raised to the negative half power. I want to write that something as a fraction. 4 is 4 over 1. Just like plus tells you to add and minus tells you to subtract and division and multiplication, etc. In the exponent, if you have a minus sign, it just tells you to flip that over. That's what the minus sign tells you to do. What times itself 2 times gives you a quarter? A half. So the first power is still a half. If you prefer, you can think of this as 1 to the half divided by 4 to the half. 1 to any power is 1. Because 1 to the A over B, regardless of what integers A and B are. What times itself B times gives you 1? 1. 1 times 1 times 1, B times is 1. Raise it to the 8th power. That means multiply 1 by itself 8 times. 1 times 1 times 1, it's 1. 1 to any power is 1. 4 to the half, well, that's half means square root. Most of you are familiar with square roots, and square root 4 is 2. So however you do it, get the right answer. The negative sign in the exponent is just a command or a request to flip over the base. If you have 2/3 to the negative 2, this negative sign says flip over the base. And now we're done with the negative sign. Don't put it back. I mean, if you put it back, well, then it tells you to flip over the base. And if you put it back, it tells you, that negative sign tells you to flip over the base. I mean, this is silly. This is silly. In fact, I think none of them are correct. Because once you flip it over, there is no negative exponent. 3 over 2 times 3 over 2 times 3 over 2, 27 over 8. 3 times 3 times 3 is 27. 2 times 2 is 4 times 2 is 8. That is all you do with negative exponents. The negative sign says, oh, flip over the base. If there is no base, well then, I mean, if there is no denominator, put 1. put 1. So this is 1/4 to the 1/3. 1 to the 3rd divided by 4 to the 3rd. 1 to any power is 1. What times itself 3 times gives me 4? I don't know. 1 times 1 times 1 is 1. 2 times 2 times 2 is already too much. So then compute 4 to the 1, which is 4, and then take the cube root of that answer. So 1 over the cube root of 4. And yes, you're not supposed to have radicals in the final answer in the denominator, but that's for a whole nother section. Now, I do want to point out one thing. You cannot compute this. You cannot take the square root of a negative number. This is no solution. You can take the square root of 16. It's 4. Now, this here represents a number. Represents 4. How much is this? 4. Somebody puts a negative sign in front of it. It is negative 4. This exponent is only for the base 16. I mean, think of it. If somebody asks you, what is 25 minus this? You would say, well, that's 25 and this is 4. 25 minus 4. Well, if you ignore the 25, yeah, take away 25 from both sides. That means ignore it. Then you have negative 16 to the half is negative 4. This here is not the same as negative 16 to the half. This is negative 16 to the half, and this is negative 16 to the half. Sounds almost exactly the same, but the brackets say that what's being raised to the half is negative 16. What's being raised to the half down here is 16. And whatever that is a negative in front of it. What's in that circle is 4. There's a negative in front. Okay. Understand this. If it makes it easier, put a number in front of it. Again, if you have negative 4 to the half, you're like, oh my, I always forget this. Well, put 10 in front. Well, this is 10 minus, 2. 10 minus 2. Well, there really was no 10. There really was no 10. There's the answer, negative 2. Now, if you do it with the other one, negative 4 to the half, and you put a 10 in front, oh, that's multiplication. That's not even, I think it's very clear now that that negative sign is attached to the 4. It's negative 4 that's being raised to the half, not 4 raised to the half with a negative in front. This troubles people so much. That's why I'm just going on and on about it. Now let's just multiply exponents. Well, that's not true. Let's multiply things like this. X to the third times x to the 4/3. And here's a nice little trick to remember. You learned how to add and then multiply and then exponents. Learn how to add, multiply, and use exponents. This problem is multiplication. Go down one level. Addition. That's what you do with the exponents. You add them. 1/3 plus 4/3, 5/3. Go down one level. x to the 1/4 times x to the 1/5. We are multiplying. Students say, oh, this is an addition. No, it's a multiplication problem. So down one level, you might add the exponents, but it's still a multiplication problem. 1/4 plus 1/5, the LCD is 20. Multiply by 5 over 5, and you get 5 over 20. Plus, multiply by 4 over 4, and you get 4 over 20. 5 over 20 plus 4 over 20 is 9 over 20. And there it is. Repeated addition is multiplication. Repeated multiplication is exponents. 7 times 7 times 7 times 7. That's 7 to the 4th. Exponents. Subtraction. Repeated subtraction is division. You have 18 and you want to do 2 into 18. Well, 18 minus 2 is 16. I took away 1. Minus 2 is 14. I took away 2. Minus 2 is 12. Minus 2 is 10. 10. Minus 2 is 8. Minus 2 is 6. Minus 2 is 4. Minus 2 is 2. Minus 2 is 0. 9. It's repeated subtraction. And repeated division, we'll also call that exponents. So, if you had powers where it was involved in division, powers and exponents are the same. You have x to the 7 divided by x to the 3. Just go down 1. Division, subtract. 7 minus 3 is 4. But you should really see this. This here is x to the 7 divided by x cubed. This is x to the 4th. Why were there 4 x's left over? Because the top number, 7, was 4 more than the bottom number. How do you find out how much bigger one number is than the other? You do subtraction. So, if you have x to the 5/3 and you divide by x to the 2/3, you subtract the exponents, you get x to the 3/3. I guess if x is positive, you could say, I'm terrified of saying that that's 1. As I said earlier, you can't mess with the exponents. But if x is greater than 0, this is x to the 1, which is x. You really should think about whether or not it's going to matter. And since it's odd, it won't matter. Since 3 and 3 were both odd, that's another reason it won't matter. Now, we have addition, multiplication, exponents. You have x cubed to the 5th power. This is exponents. Go down 1. We're raising. That's the, see here, if you had x cubed times x to the 7, this is a multiplication problem. But now we have something. I don't care that it has an exponent or not. We have something to a power. That's exponents. Go down 1. Multiply. 3 times 5, 15. Just go down 1. 3 times 5 is 15. So if you have x to the 3rd times x to the 5 over 7. On the side, you compute 1/3 times 5 over 7. 1 times 5 is 5. 3 times 7 is 21. X to the 5 over 21. Just a little bit more. Suppose you have a to the 3rd, b to the 5/4, c to the 2/11 over d to the 4/5, and e to the 3 over 13. And this gets raised to the 7 over 2 power. Every factor, factors are the things that are being multiplied or divided. A to the 1/3 times b to the 5/4 times c to the 2/11 divided by d to the 4/5 divided by e to the 3 over 13. A to the 3rd, b to the 5/4, c to the 2/11, e to the 4/5, and e to the 3 over 13. Those are the factors. Each of those factors gets raised to the 7 over 2 power. Now, I would not advise you to write this. It's not wrong, but there's no need to. But this is really what you have. Each one of these factors is being raised to the 7/2 power. So all you have to do when you raise something to powers, you multiply the powers. Whether you look here or you look there. This is a to the 7 over 6 times b to the 35 over 20. 5 times 7 is 35. 4 times 2 is 8. C. Just multiply 2 over 11 by 7 over 2. The 2's cancel. You get 7 over 11. In the bottom, 4/5 times 7/2 is our 14/5, I guess. E, 21 over 26. Okay, just multiply. Just multiply. You have 3x to the 3rd, and you multiply by 2x to the 2/3 minus x to the 4/3. And you multiply. 3 times 2 is 6. Add the exponents. 1/3 plus 2/3 is 1. I won't write that. Minus. There's an understood 1 there. 3 times 1 is 3. You add the exponents. I meant for this to be 4/3. 1/3 plus 4/3 is 5/3. There's the answer. Okay, that finishes this section on rational exponents.